Hello and welcome. Before we get started today, I would like to give a shout out and a big thanks to one of my viewers that commented about my lighting issue. I was casting shadows and I didn't even realize it. I'm new to this whole YouTube thing, but I really appreciate that comment, and hopefully this takes care of it, and I hopefully took care of the sound issue as well. Before we get started on going over the 74LS14 Hex inverter, I want to go over the breadboard for newcomers to the hobby. A breadboard, your work area is from here to here. Okay, you have this divider in the middle that divides this side from this side. All the points, or all the connections from here to here is connected. All the connections from here to here is connected. All the connections from here to here is connected, and so on. They're not connected across like this. Same down here. All these are connected, all these are connected, and all these are connected. None of them are connected going this way. Your power rails on the sides, they are all connected going the length of the board. Okay, with that out of the way, it looks like a complicated thing, but it is very simple. Alright, with that out of the way, we're going to move on. The 74LS14 is a Hex Schmitt trigger inverter. It is used primarily to clean up dirty signals, and I would like to demonstrate that for you right now. You can use it to debounce switches or clean up dirty analog or digital signals. So we're going to start out. I'm going to grab us some jumpers. Okay. Pin 14 is your positive. Your VCC to the chip. Pin 7 is the ground. Okay. We got a 330. We're not going to even do that. I'm getting ahead of myself. And yes, everything here is unedited. If I have a brain fart, you'll know it. Okay. We're going to put a capacitor from negative to one of the points up there. This over here is just a logic clock with the 555. And we're going to plug the output of it to the positive lead of our capacitor. Okay, we're going to go from there, same point, right there, alongside of it, and we're going to put our scope lead on it. Well, let's get us a ground for our scope lead. Okay. Put the scope lead up. Okay. It's to the ground. Get that out the way. And we'll plug in our power supply. Alright. Oh, I made a mistake already, guys. That wasn't my output. That is my VCC and ground for the 555. Here is the output. It was hiding. Okay, back to where it was. Alright. So now we're going to turn on the power. And we should, well, it looks like my timer is set just a little too slow. So we're just going to see if we can get it going a little faster here. All right. Now, we'll take a look at the scope. And as you can see, that's not a clean signal. You can see the charge and discharge of the capacitor. Bring that camera back down. And we're going to clean that signal up using the Schmitt trigger. I'm going to take the output and put it to pin 1. That's the output from the clock going through the capacitor. We're going to go from pin 2 back to our scope lead, just like that. We're going to go back up to the scope, and as you can see, that is a nice clean square wave, sharp rising and falling edges. That is the main purpose of a Schmitt trigger. But that is not the only use for the chip. We're going to shut our power down. Pull the scope lead. Okay. And we're going to get rid of the clock. Move him out of the way. We're going to take this capacitor and we're going to go from pin 1 to ground. Always be sure the striped side of your electrolytic is towards the ground side of your circuit. We're going to take a 330 ohm resistor and we're going to go between pin 1 and pin 2. If I can get it to go in there. There we go. Alright. Then we're going to go from pin 2, get it in there, over here somewhere on the breadboard. And we're going to use a drop resistor from our output of the Schmitt trigger over here to another point on the board. We're going to take an LED and go from the negative to that lead of the resistor. We're going to turn our power on and see what we get. Well, I don't know if you can tell that it's flashing. Let's see if we can step it up a little bit here. Let me find another capacitor. Pull out the capacitor drawer and dump them everywhere. That's about normal. Okay, we're going to go with shut this off. Let's see what we got here. We got 100 microfarad, I believe. Yeah. So we're going to go with a 680 microfarad. And you can adjust your timing on this oscillator by changing your resistance value and your capacitance. So we're going to take that and put it from positive side to pin 1. Okay. And negative side of your capacitor to ground. Let's turn it back on. Yeah, that slowed it down quite a bit. You can see her flashing. You can build an oscillator. Schmitt trigger oscillator. And you can keep adding because there are 6 Schmitt triggers in there on that one chip. So say we want to go with a different. We're gonna, okay, we went with a 330 on the first oscillator. So let's work around the camera here. Let's go from pin 3 to pin 4, the resistor. Okay. And we're going to try this 100 microfarad again from pin 4, or pin 3 to ground. And I ran out of jumpers. Get some more jumpers. I think we're in business now. We'll go from pin 4 off over here somewhere. And we're going to need another 220 ohm resistor. Let's see if I can find it. Well, I don't know what that was. That was a weird noise. Hope something didn't fall on the roof. Okay, we're going to go from that output over here to somewhere on the board. And I had another LED laying here, and I'll be darned if I misplaced it. There we go. Found it. Okay, we're going to go from the ground up to it, up to the leg of that resistor. And we're not oscillating. Oh, because I forgot a lead. Got to go from pin 2 to pin 3. Nope, that didn't work either. What in the hell is going on here? Oh, well, I missed my hole. There we go. It's hard to see around this camera. Not used to it. There we go. We got two different frequencies of oscillation from that one chip. Play with it. Play around with it. See what you can come up with. Police lights, railroad crossing lights for your model trains, you name it. But I wanted to share this circuit with you, this IC, because I had a few people on a group that I was in saying they were having trouble with the switch going to their microcontroller. They'd hit it and it would on and then back off again, and that was because of the bounce in the switch. I hope you enjoyed this video. There will be more to come very soon, and like I said, it is completely unedited. What you see is what you get. I absolutely refuse to edit. I hope you enjoyed. If you did, give me a big thumbs up. Hit the subscribe button and the bell icon so you'll get notifications when I put out another video. And I'll see you next time. Goodbye.